Hi everyone, and welcome to another stream with a huge break as usual. I'm kinda using this streaming thing not as one should, but let's see how it goes. Today I want to work on a small thing, maybe I already made some testing prototyping shit, and I want to work on picture to pixel art-ish thing. So you would put the picture in and then the code transforms it into the pixel art stylish thing. Basically pixelate the image. And yeah, that would be a goal for today. First of all, I need to test a couple of things. The sound. Okay, that works. Okay, now I hear myself too. Good. So the whole code will be available on GitHub. I'll put the link later in the description, and I think we'll be able to start soon. You. Okay. I believe chat works too. Yeah. And yeah, my suggestion would be to start with some README file and work on the tasks. The project is titled like pixel this and that. What we want to do is like make a small like to-do-ish list. So what we want to do is basically input JPEG, PNG, and plus color palette, and to have output pixel art. We call it pixel art, but it's not actual pixel art. So what we want to have is several steps. First step would be actually to reduce the size of the image. So what we like read file, then Привет, Dima. So Russian speakers up on board. Yeah, so first of all, okay, so sound issues. Wait a second. Okay, that might be something with my what is it? Like motif? Probably it's a limiter on my microphone. Wait a second, I'll update my app. Yeah, that's not what we want to have. Start history. Yeah, it looks like my Shure microphone app is not starting, so and it's not working properly. Wait a second, like it will take a minute or so. Yeah, I mean, music comes from the different place than my voice. Like my voice comes from clean from the USB-C, like connected. It's like a separate audio device, and the music comes from the files. Or you mean like it's music and voice? Okay. How about? Okay, I reduced music. So how about now? Okay. Thanks, Dima. Yeah, I believe a bit bigger text would be nice. Okay. Then. So yeah, where was like read file, and after we read file, and we need to reduce size of file. Then we need to like basically, yeah, we reduce size and there's like pixelation, but we need to fix the size of the pixels, like keep them big enough. And then we need to also quantize color of each individual pixel of pixels to palettes that we define, we input. And I'm not sure about the order, but we also need to do dithering. It's necessary, otherwise we would have like every picture that has gradient or any variation of the color on the overall same color. Like let's say you have like a table written with light. Some parts of the table will be darker than some with a higher hue and intensity. Then you don't want to have this like individual pixels lit up on this surface. So dithering would help us with the gradients. And yeah, basically then output image generation. Then what I would do is also make file to run against multiple inputs. So my idea is like just simplify how we can run program. To start, what I want to do is initiate Go module, Go mod init. Yeah, basically this one. And then what we'll do is to in Go create a thing. And what I'm going to do is to simplify all these things. It's to have like input or directory and and output directory. So this would be a bit easier then for us to work on. Because yeah, we will have like a batch-based thing. We just put in the files, run the program. We'll have like all these files converted. What I want to do is like, I don't have a plan to make out of it any web interface or any interface thing. What I want to do is to make a command line like read the CLI commands flags, and this would simplify usage of the thing, I assume, like at least for the development phase. So the default would be I assume. Thanks, Ruslan. path to file to convert path to image to pixel art. Output path. This would be like a default thing, like we can always change it, but then okay, then yeah, we just go here first. Yeah, everything. Just checking if my stream works. So what we weird, my keyboard just disconnected. Keyboards with battery, it's disaster. Okay. So like we read file. Okay, so we have image, and it's all by now it's all standard labs. I don't know, like I usually use other log library. Okay, whatever. Like it's not that important. Resize. What we want to do is to resize image, and for the image resizing, there's a library called Imagine. Here's like GitHub library link, like, and this basically allows us to work with image, like define the sizes and stuff. Fairly simple to use. What I would do is so first of all, let's resized img and imaging resize, and the interface of this thing was we need to tidy go mod vendor. If you ever seen how I code, like I'm pro vendoring. So so like this has like input image, width, height, and resampling filter. We can like have a different resampling approach. So there's a couple of algorithms to do this. We can play around with these things. So basically, look what works best for us. It's not. I don't know. Like we can photography using the sharp result. We don't really. We need something that produce like biggest amount of pixelation, so we can work with these pixels. For downscaling, when upscaling, it's similar to the neighbors. Okay, yeah, we can do nearest neighbor. Look into the nearest neighbor option and work with that. What we need though, it's wished size. We don't have any value. Like we can go with like, I don't know. Let's go with 128 pixel with 128 pixel. With this, of course it would change the ratio, but for most of the pixel art-ish things, it should be fine. Otherwise, we can also define like with the input values, and imagine No, wait. We need this. Does not return error. So the next step would be actually, so we made it smaller. Let's go to the read file, reduce size, context. We need to go through the each and every pixel and assign this pixel new color, but we don't have palette yet. Maybe we can go output. Maybe we can just like try if the image that we like downsized works. To do so, we need to create a new file in the file system, and this would be awesome. Create. We have this output path. If error. One of the most important things with this, I would say, like always, do not forget to close the files. Otherwise, be hard. Yeah, to debug memory leaks, or like have like condition, the race condition, like you have like lock on file, and yeah, I don't know, like I'm not using this file in this code many times, but it's still a good idea to close these files. maybe just like, I don't know. Just as a message, and let's make a mic file, because like we would be running this thing again and again, and this might require us to do this a lot of times. And I want to have here in input, I want to have files. Like I already prepared a couple of images that I would like to try on this, and we would run this make file, and this should do this thing. My images. Okay. I used Unsplash for this purpose, and these are some images. I don't know how they will work, but yeah. Let's try with it. And what we want to do is we want to run this basically program on every file that is, like, we want to run this program on every file that's in the input directory, and output these images to output directory. So what we need is also cmd, like what's like the command that we're running. So the cmd of would be go run main.go. So and then there will be input output values, and I've prepared a couple of approaches here to do so. And for input directory, so basically every file in this input directory what was the command? Would it be this file? then output. Okay, output. So we need output file. Like file here is actually like whole path of it. So what would we need? A variable that holds file that holds the original file thing plus like original file name. Right. File name. Then output file name would be this output directory plus the file name. Then we can use it here, I assume. Wait, right? Let's make process make clean. Yeah, okay. Why process does not work? Did I write it correctly? No rule to make outputs. Ah. Okay. So I don't have folder code like it's typo output. Okay. Okay. Output command not found. File. tripping or what? Okay, now it's working. Just typo. Good idea to add a new line there somewhere. Okay, this was our input and output. Okay, downsizing works. So it's this one. It's 100 by 128 by 128 pixels. Yeah. Next thing would be, okay, resizing works. Next thing would be, we need a thing to map colors pixel by pixel. But before we start, we need a palette. I have this like a website called I used for when I was like in pixel art interested. Lospec. Kind of really like what's available there, and I went there and selected a couple of palettes that I think might be good, and where's this? So like different approach, different colors. Maybe it will provide different results as well. So what we gonna do is to actually, it makes sense is to we take every pixel and try to find the matching color. Like we take color of the pixel that we have and try to find a color that's closest to the color from the palette. So there's different approaches to that. One is like we just compare the distances of the color on the how would you call this, in this dimension of in this space of the colors distribution. Like real colors are not just a wheel of the colors, but that's like can be defined differently mathematically. And there's like just a RGB thing, and there's also a thing called Color Lab. And more how we perceive them as a human beings. And I've prepared here a couple of like approaches to do this. And this is actually like tested thing. I think like first of all I put it here. There's a library called Colorful, and I would suggest to check it out how it works inside. It's a really interesting thing. Yeah, we'll need to download this yet. And this thing allows like our color palette will be defined exactly this way, like color.go as an array of it, It can be 2 colors. If it's one, of course, it will be everything. But if it's 2 colors, at least 2 colors. But the more colors you have, the more realistic it would be. So you want to be in the sweet spot that you have like countable on 2 hands amount of colors to have this pixel artish feeling. And then you have single color that you, so basically this is our input color. See, it's like input color. And it tries to find which one out of this palette is the closest to this scene. And this one using this distance lab, like you can think about this. You have this dimension with like 3 axes, like RGB, and you want to try to find. So you have, and at some point, like point X, you have your color, and there's like other colors and the dots, and you just trying to find the closest distance to it across all these dimensions. This can be more than 3 dimensions theoretically, like if you use luminescence and all other stuff. But overall, for our purpose at this moment, it's fine. This function can be improved in many ways. This means we just go through pixel by pixel this thing, basically. Bonds. Okay, yeah, we don't have this palette yet. what would be the default? Okay, yeah, let's take some default string here. Yeah. Right. I believe we don't need escapes here. Kinda too many colors. I don't know. I don't know if it would be a good idea to remove last ones. They're kind of distributed. Custom color. Should be at least 2 colors. like thinking, what if what if no palette color is defined? Like, oh, what should be some default one. If and let's take this one as a default. If then we have always some color defined. Maybe it makes more sense. Palette string. So this should be kind of optional value. If we have, okay, we have so we have a visualized image. Then we got like the bounds of the image, like amount of like pixels in it, and we created a new image, but with the same sizing. Then we go from like 0, 0 to in x epsilon and to max x epsilon, and yeah, where right. Yeah, so we go from by each pixel by pixel. Each pixel by pixel, and then we have we say, okay, here's like position of this pixel. We get at the end we return what's the color of this pixel in this format, and then when we have this this algorithm called closest color lab, where we need to pass this original color and palette, then it would return a new color that we want to map our image to. Then did I forget here something? No. Return output, yes, and second what it wants. I forgot something here. Okay, this struct. Ah, okay, the type is different. Okay, let's do it this way then. Follow it's A. I'm kinda not getting it. Color. Okay. Ah, okay. It's a pointer. Okay. Let's do this. I really don't want to work with these pointer things here. Palette. Okay. Color palette is here. Okay. Not smart idea to name it this way. Okay, deco. Okay, we have these things. This one too. Okay, let's try a process again. this one. Okay, this should be already some kind of result. Okay. Okay, yeah, we need to maintain aspect ratio. But yeah, we already can see the some color replacement. But maybe let's do other color to see if we let's try way less values. Okay, it's finished. It's not replacing colors. So image, resized image. Okay, we have resized image. Okay, yeah. We not we output in wrong, like here should be, yeah, the correct one. Okay, now should be some result. Yeah, right. Yeah. Okay, now colors are replaced. Now colors are replaced, but aspect ratio is gone. What we can do with that is we can resize image back to original, back to the original size. Colored one. The same one, but we say like imagine and resize basically the same as here. Yeah, okay, resize. And here should be like the actual like recolored one, and here we need the input image, what was it like first? Input image thingy, and we need also filtering algorithm. We can take the same one as we used for original resizing. Maybe changing would make better results. But what the idea of behind this, it's when we're resizing back and you pick the nearest one, that means missing pixels will be replaced with the nearest, like, well, what makes most sense is what basically resampled. And this might lead to some interesting results. Since we go in for more feel, should be fine. I don't know, to be honest. Let's see results. Okay, so now it's something. Okay, it's resized back to the same size as you see. So this was the original picture, and this is now. I kind of like this one. As you see, where it's like really close colors doesn't work. Maybe with other palettes it would work better, but sometimes the colors are too close to each other. It makes it basically unrecognizable. Like for the system, like for the algorithm, finding the closest color, it's basically same. Don't forget we have like 1, 2, 3, 4, 5 colors, which might be not enough. Or maybe the sizing. What if we make it a bit bigger? Let's say twice as bigger. Did we? Okay. Okay. Yeah, it looks a bit fine. This one looks good. And this one is even better. Yeah, it doesn't work for all images, definitely, but for some, it works. Yeah, basically that's it. what we can do, it's dithering. There is I will transfer Wikipedia dithering or there's algorithm for ordered dithering, and if we would apply this to this image, this would make this gradient colors better, like basically transition from one color to other color. Maybe I will leave it for the next time. Yeah, basically that's it. I think, yeah, that's you can I'll push the changes and wrap it up. Okay. Whatever. Maybe. I forgot here, like I have I forgot here is a Vim. yeah, that's it. I'll put the link to this repository in the description. It was kind of tough one tonight. Like it's his first time since a long break. Thank you for everyone who joined. And yeah, I'll try to repeat this this next week. And show something more interesting. It's a bit more attention and brain power consuming than I remember, but still was fun. Link to this repository you can find in the description a bit later. But yeah, for now, thanks for joining. Have a nice one. See ya.